Hello student, in this video I'm going to explain to you how to evaluate the line integral of xy minus x squared dx plus x squared y dy over the curve C over the curve C, where the curve C is given by y is equal to 0, x is equal to 1 and y is equal to x. So what we need to do now is, first of all, what you have to do is draw the graph of y is equal to 0, x is equal to 1 and y is equal to x. So let us draw the graph of this three given curve. Let us first draw the xy axis. X is equal to 1 or y is equal to 0, it means that it lies along the x-axis only. Then next, x is equal to 1. X is equal to 1, so let us draw the graph of this. Suppose this is a point 1 on the x-axis. So you draw a line which is parallel to the y-axis and passing through x is equal to 1. Then for this y is equal to x, you can construct a table. Let us. So here for y is equal to x, x is equal x and y when x is equal to 0, y is equal to 0, when x is equal to 1, y is equal to 1, when x is 2, y is equal to 2, and so on. So now this one is x is equal to 1, and this is given by y is equal to 0, that is the x-axis, this is the origin. Now let us draw the graph of this one. If I take this one as 1, then let us mark the point somewhere here as 1. 2. Can mark this as 2. Now let us plot this graph y is equal to x. When x is equal to 0, y is equal to 0. When x is equal to 1, this is 1 here. Y is also 1. Let me change the color of this. So here, if you plot this point, when x is equal to 0, the value of y is also 0. When x is equal to 1, that is this point, then y is equal to 1. So that means this graph will meet there. It is a straight line which passes through the origin and meet the line x is equal to 1 at this point. So this is 1, 1, and this graph is represented by y is equal to x. So now we have to evaluate this line integral over the curve C, where the curve C is given by this y is equal to 0. So let me mark this point here as A, this as B. That means we need to calculate the value of this line integral along the curve OA, AB, that will be the direction. And then the last one is y is equal to x, so it will be downward. So this is the direction. Okay. So let us evaluate this graph now. The given curve C is this one, represented by y is equal to 0, x is equal to 1, and y is equal to x. So now let us calculate. Therefore, the line integral of what is that given function? xy minus x squared, xy minus x squared dx over the curve C plus x squared y dy. Okay. So this will be equal to the line integral. One is y is equal to 0. It means along OA. And then x is equal to 1. Let us see from the figure. X is equal to 1. That means along AB. So this will be along the line AB. And lastly, when y is equal to x, it is along BO. So therefore, this given the value of this line integral over the curve C can be written in this way. Now, C is a curve represented. The first one is along the line OA, the second one is along AB, and the third one is along BO. So you can split it into three parts. Xy minus x squared dx will remain as it is, minus x squared y dy along OA, the first one, plus again the integral inside the integral sign will remain as it is, xy minus x squared dx plus x squared y dy along AB. Can take this one part, and then the last one will be plus the line integral xy minus x squared dy or dx plus x squared y dy along the curve BO. Let us name this one as equation star. Now, along the curve OA, let us see, along the curve OA, you can see from this figure, what is y? Y is fixed as 0. So y is equal to 0, which will implies that dy also will be 0 along OA, and x varies from where to where? X varies from, see, at this origin, x is equal to 0, and at this point, x is equal to 1. So x varies from x is equal to 0 to x is equal to 1. That means along OA, the value of this dy will become 0. Y also has to be replaced by 0. Then you'll get the integral only in terms of dx. And then the limits of integration will be from 0 to 1. Now next, let us see along AB. Number 1 is this. Number 2, along AB. What is fixed in this case? Along AB, you see that y varies in this case, but x is fixed as 1. So let us find out what will be the limit of integration. Along AB, x is equal to 1. Being a constant, so this will imply that dx is equal to 0. And y varies from, we can see from here, from the graph, this one. You can see here that at this point, it is 1, 0, the coordinate, and at this point 1, 1. So you see that y varies from 0 to 1. So the limits of integration now for y will be from y is equal to 0 to y is equal to 1. And lastly, it will be along BO. Along BO, you can see that along BO, what is y? Y can be replaced by x. And x here varies from 1. And at this origin here, what is the coordinate? It will be 0, 0. So x varies from 1 to 0. And you can replace the value of y in that integral by x. And if y is equal to x, it means dy also will be dx. log BO, y is equal to x. So which means that dy will be same as dx, and x varies from, you can also evaluate it at, with respect to y, that is you can replace dx by dy here, but without loss of generality I am taking this one, change it in terms of x, and then the limits of integration for x is from 0 to 1. If you replace the value of x in terms of y, there also you see the limits of integration now for y will be from 0 to 1 again. So here x varies from x is equal to 1 to x is equal to 0. So therefore equation star now will implies what? The line integral over the curve cxy minus x squared dx plus x squared y dy is equal to, along OA we see that y is equal to 0, and let us see what are the remaining terms there. It will be the integral. Now here you see that x varies from 0 to 1. Then it will be x into 0 because y is equal to 0 along OA, then x squared dx plus it will be x squared into 0 d0 or dy also is 0 plus along AB. Along AB we have x is fixed as 1, so it will be 1 into y minus 1 square dx is equal to 0 here plus 1 square y into dy, where y varies from 0 to y is equal to 1. Here it means x is equal to 0 to x is equal to 1. And lastly, this one along BO plus it will be the integral along BO. And we see that along BO, x varies from 1 to 0. So x is equal to 1 to x is equal to 0. Now it will be x. For y, you can replace it by x because we see that along BO, y is equal to x. So you can replace this y by x. So it will become x into x minus x squared dx plus x squared y. But y can be replaced by x itself. Then what is dy again? Since x is y is equal to x, so dy will be same as dx. So let us simplify this one. So this will be equal to, now in the first integral you see that only that 0 to 1, then minus x squared dx will be there, and in the second integral we'll have this part will be 0, so it will be just y dy. You'll have y dy where y varies from 0 to 1, and in the last integral or the third integral we have the first integral will become 0 because you'll get x into x, it will be x squared. X squared minus x squared will become 0. So you'll get x cubed dx only will be there. So you get x cubed dx from x from 1 in this case, from 1 to 0. So let us integrate, it will become minus x cubed by 3 from 0 to 1 plus y squared by 2 from 0 to 1 plus x to the power 4 by 4 from 1 to 0. So this one keeps you what? It will be equal to, minus can keep it outside, it will be 1 cube. So it will be 1 by 3 minus the lower limit, it will become 0 only. Plus here it will be 1, replace y by 1, then it will become 1 square will be 1, 1 by 2. Minus again y by 0. If you substitute the lower limit, then in that case it will become 0. Plus now here it will become 0 by 4 minus, since the lower limit is 1, so it will become 1 to the power 4 will be 1 by 4. Let us simplify this one. It will be minus 1 by 3 plus 1 by 2 minus 1 by 4. And what is the LCM here? It will be 12. So in this case it will become it will be minus 4 plus 6 minus 3 divided by 12, and this is equal to minus 4 minus 3. It will become minus 7 plus 6 by 12, which is equal to minus 1 by 12. So this is the value of the line integral when the given curve is given by y is equal to 0, then x is equal to 1 and y is equal to x. So you see that in order to integrate this line integral, first of all you draw the graph of y is equal to 0, x is equal to 1 and y is equal to x. When you draw this graph, then you can split that curve C into 3 parts. That means the integral of this one first along this first line, that is along OA, that is y is equal to 0, then next along x is equal to 1, that is along AB. And you can see what we notice from this graph is that along OA, y is equal to 0. And then if you differentiate this y is equal to 0, you get dy also will be 0. And we can see from here that x changes from 0 to 1. So the limit of integration will be the limits of integration for x will be from 0 to 1, and then dy dy will vanish, and then y also has to be replaced by 0. So you'll get the first one as integral with respect to x. Now along AB you can see that x is fixed as 1, but the value of y varies from 0 to 1. So here, if x is fixed as 1, then it will imply that dx will be equal to 0. And then in the second integral, that is along the line AB, this part will vanish. Then x has to be replaced by 1, and then it will reduce to a line, and it will reduce to the integral with respect to y only. And the limit of integration for y will be from 0 to 1. And lastly, along the curve y is equal to x, that is this line which passes through a straight line which passes through the origin. Then you see here that we have y is equal to x. So what you need to do is, for y you can replace it by x, and then for dy, what will be dy from here? It will be dx. You replace dy by dx and then y by x, so that it will reduce to the integral with respect to x only. And from here you can see that x varies from 1, and then at the origin it is 0. So the limits of integration for x will be from 1 to 0. So hope it is clear now how to evaluate this line integral along the curve y is equal to 0, x is equal to 1, y is equal to x.